The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
I'm going to work through problem number 8 for Physics 2020, Midterm Exam 2, year 2006. And this problem says that you have a ball of mass 0.22 kilograms, and it's moving with a speed of 7.5 meters per second in the positive x direction, and collides head-on with a 5.0 kilogram ball at rest. If the collision is perfectly elastic, what will be the velocities of the two balls after the collision? And it says, let the sign designate the positive or negative x direction, and the velocity of the small ball is listed first. Okay, so we have basically the problem statement written here. And so we have a smaller ball that is 0.22 kilograms. Okay, so we have, let's say we have a small ball here, and this is 0.22 kilograms, and its initial velocity, okay, is equal to 7.5 meters per second in the positive x direction. All right, and so this ball is going to be traveling, and it's going to hit some bigger ball, which is 5.0 kilograms, and it's initially at rest. So its initial velocity is at 0 meters per second. And if we designate the small ball as 1 and the big ball as 2, then we can basically set up our coordinate system where we have the positive y in this direction going up and the positive x direction going that way. What else can we extract from this problem? It says that the collision is perfectly elastic. Okay, so since it's perfectly elastic, we know that kinetic energy is conserved. In addition to kinetic energy, momentum is also conserved. So kinetic energy and momentum are both conserved. Okay, and this is important because we know that so basically it's asking us what will the velocities of the two balls after collision. Okay, so what are the velocities of the two balls after the collision? The first ball is going to be traveling at 7.5 meters per second. It's going to hit the second big ball, which is at rest, and then it's going to have a head-on perfectly elastic collision, and the two balls are going to then move after the collision with some final velocity, which we don't know, which we're trying to determine. So in order to do that, we can look on our formula sheet, which is given for this particular exam. And if you look under totally elastic collision, you'll see that kinetic energy and momentum is conserved. And you have two equations, basically. On the first equation, you have, this is your kinetic energy equation. You'll have basically the kinetic energy of the two balls initially is going to equal to the kinetic energy of the two balls after the collision, because kinetic energy is conserved, so there's no change in energy. So we can write this basically what this says is that the kinetic energy initial, the subscript I stands for initial, of the first and second balls, okay, is equal to the kinetic energy, the final kinetic energy of the first and second ball. So basically there's no change in kinetic energy. And so the lower subscript I means initial velocity, that's before the collision, and the subscript F means final velocity, that means after the collision. Okay, and we have another equation for momentum. And basically that says that the momentum of the first ball initially plus the momentum of the second ball initially is equal to the momentum of the first ball after collision plus the momentum of the second ball after the collision. Okay, so you'll see that we have two equations. Okay, and the reason why we have two equations is because we're trying to find the velocities of the two balls after the collision. So we're trying to find the final velocity. So we're trying to find what we call V1F and V2F. So this is the final velocity of ball 1. And this is the final velocity of ball 2. Okay? So we're trying to find these two unknowns, and in order for us to find two unknowns, we have to have two equations. And if we look at these two equations, we know the mass of the first ball, we know the initial velocity of the first ball, we know the mass of the second ball and the initial velocity of the second ball. What we don't know are the final velocities. So we have two unknown variables in this equation, and again, we know all this information, and we don't know this information, the final velocities, okay? So again, we're trying to find the same two unknown variables. We have two equations. What we could actually do is we can do some algebraic manipulation and solve for one of the variables in terms of the other, plug that back into the equations, the first equation, and you can basically get a single equation with one variable in it, and you can find that, you know, that velocity, and then once you find that velocity, you can plug that back into the second equation. That is a kind of a long derivation, so I'm going to give you the two equations, the two expressions that that results if you do exactly what I just said. So let's create some room here. So basically, if you do some algebraic manipulation of these two equations, you're going to get an expression where you'll have the final velocity of the first ball is equal to the final velocity of the second ball minus the initial velocity of the first ball. And you'll get an expression for the final velocity of the second ball is equal to 2 times the mass of the first ball times the velocity, initial velocity of the first ball, divided by the sum of the two masses. Okay? And so we'll call this 1 star and this 2 star. Okay? And so we've got two expressions now, one for each of the final velocities, and we got these expressions by algebraically manipulating these two equations and solving for one of the variables in terms of the other. And if you want to see actually the how we derive these two equations, you can go to the extra supplemental video for this particular exam, where I go over how to go from these two equations to these two equations. We won't do that here simply because it's a long derivation. Just know that these are the two equations that you'll end up with, and given that we have these two equations now, we can just substitute in the information that's known in order to solve the problem. So let's do that. So let's start from 2 star, all right, where we know that the second velocity, final velocity, is equal to the initial mass times the initial velocity of the first ball divided by the sum of the two masses, okay? So we know that the mass of the first ball is 0.22 kilograms. That's given in the problem. And its initial velocity is 7.5 meters per second. And since we're taking the positive x to be going to the right, then we can assume that the velocity is traveling in a positive direction. And so we divide that by the sum of the two masses, which is 0.22 kilograms plus 5.0 kilograms. And you can see that when we solve this, the kilograms are going to cancel out, and you're going to just be left with meters per second, which is a velocity. And that works out to be 0.63 meters per second. Okay, so we found one of the final velocities, and we see that it's positive. So the velocity of the second ball, the larger ball, the 5 kilogram ball, is actually going to be moving at 0.63 meters per second in the positive x direction. So what about the final velocity of the first ball? Well, we know that that's equal to, from 1 star, we know that the final velocity of the first ball is equal to the final velocity of the second ball minus the initial velocity of the first ball. So the final velocity of the second ball we just calculated to be 0.63 meters per second minus the initial velocity of the first ball, which is 7.5 meters per second. And when we calculate this, this works out to be minus 6.9 meters per second. All right, and remember that velocity is a vector, so that means it has magnitude and direction, and the minus sign indicates that we are actually traveling in the x direction, the negative x direction. So what does that tell us about the first ball? Well, since the first ball is a small ball, okay, 0.22 kilograms, and it's traveling at a velocity of 7.5 meters per second, it doesn't have enough momentum or kinetic energy to actually keep going forward whenever it hits the larger ball. In fact, it's going to collide with the larger ball and actually bounce backwards, and that's what the negative sign indicates. It indicates that it's going to collide with the larger ball, and then it's going to reverse its velocity. It's going to go backwards, negative 6.9 meters per second. So as far as the answer is concerned, it says it wants us to put the small ball is listed first, so the answer would be minus 6.9 meters per second and 0.63 meters per second. And that is the solution to this problem.
The Teaching Center, UF's Learning Support Center. www.teachingcenter.ufl.edu.